welcome all of you to come to the second sessions here. So my topic has been introduced by Professor Chen about for the cloud-based cyber-physical systems. And I think Professor Huang has already mentioned a little bit about for the cyber-physical systems. But actually, maybe you may find that this topic is quite interesting. Why in the advanced manufacturing? Because for manufacturing, you also need logistics as a backup, right? Or logistics also play an important role. In the past years, I think we try to reduce the manufacturing costs, but on the other hand, we realize that a lot of costs come to the logistic part. So that's why we come up with these topics. So here's my agendas. I will briefly talk about for the studies. And actually, this study is mainly from my ITF project and work with the industrial partners. And also for the cyber-physical systems, later I may mention my point of view about cyber-physical systems. As a lab in charge of the cyber-physical systems, we still also explore more applications and then the possibility about all the applications in different areas. And surely, apart from the system behind, we need the algorithms, right? And also, when we try to do the optimizations or make use of AI, we try to find out that, okay, which approach is more appropriate for us to minimize our costs, or even for this case is to minimize the times for the vehicle routing problems. So I think for the cyber-physical system, most of you are familiar with these terms, because as a cyber-physical system, we always want to think about that, okay, how to integrate the cyber world and physical world together. As the physical world, we always have different types of the sensor to capture the environmental data. And on the other hand, for the logistics, I think every vehicles have the GPS, right? And apart from this sensor, okay, once when we have this data, how it affect our systems. In the past, we put it into separately, right? So system work as it is, and then for the sensor, do the machining part or capture the data for further analysis. But now we try to think about how to intervene in response to the virtualized the environments. So once when we have these informations and when we simulate the environment, maybe we can come up with a better solutions. And then we can also go back to the physical world and then do the control and actuations such that it's form a closed loop rather than the single areas, right? So for the logistic aspect, I think most of the researcher, if you do the research in logistics, vehicle routing problem is not a strange term for you. You are very familiar with all of it. For the vehicle routings, we always think about that for the geographical locations, and then we need to think about how to distribute our goods and deliver on time. On time come with the very critical issues, because we don't want to buy something today and then tell you that, okay, you will receive it after 3 days, right? So we want the products almost immediately or maybe in short period of time. So for the vehicle routings, and it also come up with issues for the logistic companies and e-commerce, because when the e-commerce platform, they can provide the products, then they always link up with good logistic parties, right? So it makes sure that the goods can be delivered on time. And for the VRP, we can divide into many different types. For example, we always mention about for the VRP with the time windows. And then apart from time windows, we also think about for the backhauls, right? As mentioned by Professor Lee about for the remanufacturing. So for remanufacturing, it come up with the reverse logistics. And for reverse logistics, it's quite difficult to forecast sometimes, right? It may be ad hoc orders from the customer that they want to return the items. So how to define the capacity in the backhaul VRP. And also, apart from that, we have different types of the VRP, such as the dynamic VRP for the pickup and delivery problem VRP, or also the heterogeneous fit VRP. So because of the simplified calculations, we always make it simple. Is that, okay, we define the vehicle as one particular types, right? But indeed, for vehicles, we have different types and different capacity and different functions. So come up with that, then we would like to think about that. Okay, nowadays we always talk about for the AI, artificial intelligence. Apart from artificial intelligence, we know that one of the subcategory under AI is the swarm intelligence. So for the swarm intelligence is that you can realize that it mimic the flock of animals or insects. Okay, why the natures or the insects or animals can find out the shortest path. Okay, so what's behind? Okay, based on their collective intelligence, they know that, okay, figure out how to get the shorter path. And for the behavior, such as the social insect, then we can realize that they helps to give us some hints how to solve some complex problems. So surely, maybe some of you, when you work with the swarm intelligence, you may also think about artificial ant colonies or maybe artificial bee colonies, right? So the main objective here we would like to talk about is that we would like to intervene the physical logistic operations together with the cyber world. And in our cyber world, we would like to think about how to have the operations planning better. And also, how can we make use of our actuators to do the control in the physical world? So when we once get the real-time data, then how can we have the alignment and also have the automatic assignments for the pickup and delivery orders? And finally, as a management point of view, they don't want to just look at the number, but also maybe in terms of figures and give them some hints and then realize that what further decisions or actions that they can do based on those informations. So for visualizations of delivery status in a dashboard, it gives clear visions for the management to know that what is the efficiency of the delivery service. So maybe for this, you can realize that maybe for the VLP process, just mention about for the artificial ant colonies algorithms. So we just captured some of the latest findings. So different from the traditional one, because we also have the traditional ant systems. So we will only have one iteration best ant and the global best ant add in the pheromones. So this range of the pheromones, it gives us the trace and then find out that, okay, which track of the ant trace that has the highest intensity. So this is the preferred route that we should select. So if I just skip very quickly to go through here to let you to visualize it, then maybe for the ant colony, some of you know about it. If some of you are not in the swarm intelligence, maybe it's new for you, then take this figure as an example. You can see that as an ant, so they come from one point, end point to end point. So they will leave some pheromones, the chemicals on the track. So when more and more ants go through the track, and then they realize that, okay, maybe this track or trails is the shortest one because it has more chemical left by this ant. Okay, so that pheromones is the intensities that to show that that path has higher probability of the shortest path. Okay. So as I mentioned, for the vehicle routings, different researchers start to do the research, and also, but surely maybe they will also wonder, okay, the RIAM was something new for us in the nowadays e-commerce logistics, right? So apart from the traditional point of view that we want to have the shortest distance or lower the cost, and then we also think about, we try to minimize the accumulated time to reach our customers. And also for the route, we would like to think about that, okay, some combined shipment or the split delivery, because now the customers maybe have more expectations, right? So even they purchase online in one shot, okay, in one times, but they may not want to deliver all at the same day. in some situations. So it come up with the difficulties of the logistic companies. Maybe take the institutions, they always think that, okay, you order in one day, then surely we would like to delivery within the same or within the same day. But actually, sometimes maybe some customer has their own preference, and it leads to the complexity of the vehicle routing problems. And although they also have the min-max ant colonies for VLP, we also need to find out that, okay, what is the capacity constraint? And also, how can we set the weightings for all the factors when we consider the vehicle routing problems? So here come up with our approach about the cyber physical systems. So as we have already mentioned about for the operations, we try to improve the service and quality through the collaborations between the logistic parties. And also for the cyber physical systems, we try to think about for the interface between the physical world and then the cyber world. So in the physical world, we always have the truck parcels, consignees, waybills. And on the other hand, in the cyber world, we make use of the swarm intelligence to do some predictions, visualize our big data. And finally, we hope that, okay, through the integrations in our dashboard interface or onboard unit, it can let the driver or top management of the logistic companies to realize it. So for us, we can see that, okay, for the notations and decisions variables, but surely we won't go through all these decisions variables, but roughly, just to let you know that, okay, for the decisions, we would like to find out that, okay, which path is the most feasible path that are preferred by the logistic companies. So whether the node I to J should be traveled by the vehicle K or not. Okay, so for our objective functions, all right, so in general, we have 3 items here. So the first items is mainly about for the gain that we can do by the fulfill order, while for the second item is about for the cost of the travelings. And then the third items is about for the undelivered status of the orders, undelivered orders. So so we set some penalty there because of the undelivery. And in the real situations, for the company also told us that it always happens. So for the undelivered orders. And also when we think about for some constraint in our problem formulations, we always set, for example, time window is one of the typical constraints that we need to set. Okay, within the time windows we need to deliver to our customer. And also maybe the customer, on the other hand, will mention about the avoidance time, the time that not preferred. Okay, apart from this time period, the other times is preferable. So also for the truck capacities, we also need to set it, deliver area constraint. Some of the areas such as the drop-off point, we also have some constraint in Hong Kong. For example, after 7 p.m., loading and unloading is allowed in this area. But during the peak hours, then it cannot be dropped off. Okay, so we also set it there. And also for truck time shift constraint, because during the lunchtime or somehow more than 8 hours work, maybe they have a shift. So in our systems, we will have the first stage about for the constraint that we set about for the time windows. And also, this is one of the typical flow of the next max means and colonies computations flow. So first of all, we would like to have the initializations. And after that, then we can have the constructions by the end. And then for the initializations, we will consider different types of the constraint and then see whether that fitness values can achieve certain numbers or not. So the firmware will be updating. And if it fit with the terminations conditions, it will stop. Otherwise, it will go back again. And also, once when we collect all these solutions, then we can also have further firmware updating. Okay. So when we think about for the path of the artificial's end, we also think about, okay, whether the constraint of the node that can be fulfilled or not. So in the typical situations, the node we think about is the point of the deliveries. And also we need to think about several factors, such as we need to consider the next node. Okay, whether that constraint can be fulfilled or we can relax any limitations of the physical parameters of the vehicles and any time constraint or priorities. So all the resources that we consider in the next node, and then we come up amount of the fragments that obtained on the path of the next node. So for the optimizations or 3D search algorithms, I think most of you may be also a little familiar with it. And also the mechanisms is also somehow quite similar of the genetic algorithms. So you will go through for the optimizations through the label sorts. So we have different types of the node, and then we can sort out, maybe we can also swap it, and also have the inversions mutations. So apart from the inversions mutations, maybe we can have some insertion sorts. So we can move these node here and then change this node into the other positions. And also we can have the order crossovers. So we have copied the node there, and then we put certain node into different locations, such that we hope to overcome the local optimization so as to have more global optimizations. So once when we do the searching, we find out the possible solutions, then we can do some comparisons and select the best one. So we come up with the case study here. Okay, very quickly about for the company case. So actually for the company case, they collaborate, the logistic company collaborate with the e-commerce platform. So they are the CPL to serve the e-commerce platforms. So one of the issues is that they think about the efficiency for the manual operations of the vehicle routings. They find that always there are a lot of orders that cannot be delivered. And finally, they need to outsource to another logistic company. So it come up with a high cost and inefficiency. So we also think about for the solutions of the cyber-physical logistics systems, and then to install some sensors such as the GPS sensors for the temperature and humidity sensors, especially for some of the product required to monitoring the humidities. And also we have a small vision sensor, or we call camera, at the back of the truck, because there are also some insurance issue for the companies, because the logistic company mentioned that when the courier is not so careful to move the items, and then they collapse, okay? Once they collapse, then it come up with the insurance issues. The insurance company asks, okay, whether you have the videos, whether the products is really manually mistaken by your courier, or it is because originally the product shipped to your company already booked, right? So that's why when we install all this sensor, we capture the informations and data and then plug into the cyber physical systems. Then we also generate the routes, and then the routes can come up with the apps for the drivers to realize that which path should be the preferred path, and then which point that they should go, okay? So here are some comparisons of the manual planning and the nested MMAS. Okay, so just take a look of one of the example is that totally, if you have 69 orders, as manually, you take a long time to calculate. But with our systems, so you can see that around 1.3 seconds. So we can come up with the route. Okay, totally we require for six truck, but manually, what they find out is that, okay, what they can do is that 9 orders and 4 trucks to do the delivery. So when we try to do some comparisons, so we can figure out the difference. Although we use more trucks, but all 69 orders can be fulfilled. But on the other hand, if manually, you may find out although they use only 4 trucks, but most of the order is undelivered. Okay, so we come up with the conclusion part. Theoretically and practically, we make use of the cloud-based cyber physical system for the nested MMAS. And then also we have the problem formulations with the practical situations, and hope that through the implementations of these systems can let us to realize the directions towards Industrial 4.0. All right, so here are some of the future work. Apart from the cyber physical system, the security is one of the typical issues. So blockchain may be one of the further directions of our project. Okay, thank you very much.